Hello, and welcome to video 1 for Math 123. This is the material you're going to need to do well on the praxis exam. So we'll be talking about the praxis exam quite a bit here. In these videos, we're going to learn about real numbers, we're going to learn about functions, we're going to learn about geometry, probability, statistics. In these first videos, in this first video specifically, we're just talking about the basics. So to begin with, we're talking about the number line. So the number line is just a line with arrows on both ends indicating that we're talking about going to infinity, either positive or negative. And then we have the points along this line, 0, 1, 2, 3, etc., all the way up to positive infinity. If we're going to the left, it's negative 1, negative 2, negative 3. As we go down to negative infinity. Of course, we could have values in between this. 1.5, 1/4, negative 3.5, etc. But we just put these labels of the integers, as we're going to learn they're called in a little bit, on this line if we're just drawing the basic line. We have some relation symbols. So if we have this sort of head of the arrow pointing to the left, meaning the left side is less than the right, so this is our indication for less than. If we have this same symbol but a line underneath, this is less than or equal. So this is telling us the left side is either less than or equal to the right side. And of course, the sign you guys are familiar with, the equal sign. And we also have it if it's pointing the other way. So if the left side is bigger than or greater than the right side, we have this symbol. Greater than or equal, so it's the same symbol but a line underneath. And if we have the equal sign with a line through it, this is telling us not equal. So for example, if I have 1 on the left side and 2 on the right, well, 1 is not equal to 2. So that's where you would use that symbol. So a couple examples here. If I have 3 and 4, well what? 3 is less than 4, so I would be using this symbol here. And I know going back to like elementary school when we first learned these symbols, what they told us to think about is the crocodile eats the bigger number. If you guys remember that? So think of this like the crocodile mouth, it's eating the bigger number. It's eating the 4. What if I have 5 and negative 2? Well, looking on our number line, 5 would be way over here, negative 2 is down here, so 5 is the bigger number. The alligator wants to eat, or the crocodile wants to eat the bigger number, so 5 is greater than negative 2. And let's say I have 7 and 7. Well, I could put what? 7 is less than or equal to 7. It's not less than 7, but it is equal. So as long as I have that little line underneath, this statement is a true statement. Alright, so I'm going to leave the number line for a second. The next topic we're moving on to here is absolute value. Write that U for you guys. So the definition of absolute value is the distance of a number from 0 on the number line. because it's a distance, our answer for absolute value is always positive. So if you're working a problem and it says, what's the absolute value of X or something like that, that value has to be a positive number. So think of it, say you live at 0 and your friend lives down here in their house at number 3, and you had to, say these are blocks, if you had to walk, what, 3 blocks to your friend's house, you wouldn't say, well, I'm walking -3 blocks. No, you're walking 3 blocks, so it's a positive number. So even though you're moving towards the left, the distance you have to go is still 3 units. Therefore, the absolute value is 3. And the notation that we use for absolute value is 2 vertical bars. So for example, if I have the absolute value of 4, so where's 4 on the number line? It's out here. How many units is that away from 0? Well, it's 4 units away. What if I have absolute value of -3? So using this example like our friend's house. If our friend lives down here at -3, how many units away, how far from 0 is it? Well, it's 3 units. The negative is just telling me which direction, but the absolute value of 3 is a positive 3. So just be careful with that. When we're dealing with absolute value problems, make sure your answer is always positive. You can't tell me that the absolute value of a number is equal to negative something. It's not possible. Now, let's talk about classifying numbers. So when I was drawing the number line, I mentioned, oh, these are integers. That's what we're going to talk about here. So we have 3 different types we're going to be dealing with. The first type of number, and I should put that these are for real numbers. And sometimes you'll see me write this symbol. So it's like a capital R with 2, does that show up? Yeah, it does. A capital R with 2 vertical lines, that's the shorthand notation for real numbers. So if I happen to write that and not point it out to you, that's what that means. So for real numbers, we have 3 classifications we're going to be talking about. First of all, is our natural numbers. And the way to think about these is our counting numbers. So if you have some jelly beans in your hand, say how many is it? Well, you would count 1, 2, 3, 4, 5. You don't start at 0. You don't say, well, 0, 1, 2. No, how many? It's either 1, or it's 2, or it's 3, or it's 4, and so forth. So we're starting at 1, going up to infinity with these numbers. The second type is what's known as whole numbers. And these are the natural numbers, so these are all going to build on themselves. So it's the natural numbers and 0. Now, I'll give you a heads up here. So depending what class you take, depending who your instructor is, depending what book you're using, sometimes people will classify whole numbers or natural numbers with a 0, some without a 0. So depending on what book you're using or what class you're in, they may include 0 or not. But for our purposes, our natural numbers are 1 and going upward. Whole numbers are starting at 0, and then all of the natural numbers. And then lastly, or the third type we're going to be talking about, is integers. And these are the whole numbers and their negatives. So 0, 1, 2, 3, etc., but also going the other way. -1, -2, -3, -4, all the way down to negative infinity. All right, so that's our classification numbers. A special type of number that we have is what's known as a prime number. And the definition for a prime number is a positive number divisible by only 1 and itself, starting at the number 2. So let's think about this. What are these? Well, 2. Okay, we're starting at 2. Let's go up to 3. Does 3 divide by anything besides 1 and 3? No. How about 4? Does 4 divide by anything besides 1 and 4? Well, yes, 2. So that's not counted. So right away we know what? Every even number cannot be prime. The only time a number can be prime is if it's odd. If it's an even number, we already know it's divisible by 2. So how about 5? Well, 5 can only be divided by 5 and 1. 6 is even, we're going to skip it. 7, 7 and 1. 8, skip it. 9. Well, 9 is an odd number, so it could be prime, because is 9 divisible by anything besides 1 and 9? The answer is yes, it's divisible by 3, so therefore it's not prime. How about 10? Divisible by 2. 11, prime. 13, 17, 19, 23, and so forth. And these will go on forever, basically. It's that age-old math problem. Is there an infinite number of prime numbers? And to this point, nobody's been able to say that they stop at some point. So if you want to make a ton of money, maybe try to solve that age-old problem. You might be able to make some money there. All right, that's prime numbers. We have composite numbers, which is essentially the opposites of these guys. Composite has what word? Composed, composition. It's composed of several numbers, so it's divisible by several numbers. And these numbers that go into the numbers, into the composite numbers, are known as factors. And this is the numbers that divide any given number. So for example, let's look at the number 8. So what numbers go into 8? So the easiest way to do these, if you're gonna, because you guys will have to start factoring some numbers, my suggestion is sort of create a vertical tree here. So work your way down, and once you start repeating multiples of each other, come back up. So for example, we know what? 1 goes into 8. Does 2 go into 8? Yes. How about 3? No. 4? 4 does, but it's what? It's 4 times 2. So I'm going to start coming back up the column here. So 4 times 2, 5 no, 6 no, 7 no, 8 goes into 8. Let's try that with another number. Let's try that with 12. If we want to know what are the factors of 12, well, 1 goes into 12, 2 times 6, 3 times 4. So now if I was to put 4, I already know that it's 3 times 4. So I should turn around and come back up. 4, 6 times 2, 12 times 1. So that's a way to prevent yourself from maybe missing a number. It should, as you come back up the tree, or back up the line here, it's your multiples, and you're not skipping one along the way. So that's a good little trick. And then just a note, 1 is not prime, or composite. Own special number, we don't call it a prime number, we don't call it a composite number. All right, next, number properties. So the first is what we call commutative. And what this means is that the order doesn't matter. And this is for addition and multiplication only. So 2 plus 3 is 5, 3 plus 2 is 5. Order doesn't matter. 3 times 5 is 15. 5 times 3 is 15. Order doesn't matter. The other, or the second I should say, is associative. And this means we can group together. And again, this is only for addition and multiplication. And the third property we're going to talk about or look at is distributive. Distributive. So, as the name implies, we're distributing a number. So let's look at some examples here. Commutative we already looked at. So if I have 2 plus 3, that's 5. If I change the order, 3 plus 2, still 5. If I do multiplication, 3 times 5, 15. 5 times 3, 15. So I put the dot between the numbers here. That's our symbol for multiplication. In the homework and stuff, you might see an X, the multiplication sign, same thing. Associative. So if I have 1 plus 2 plus 3, well, 2 plus 3 is 5, add 1 to it is 6. If instead I group the 1 plus 2, and then add 3 to it, I get what? 1 plus 2 is 3, plus 3, still 6. And if you do 1 times 2 times 3, well, do inside the parentheses first. 2 times 3 is 6, times the 1 on the outside is 6. If I group the 1 and the 2 together, 1 times 2 is 2, times 3, still 6. And then our example for distributive. So let's say I have something that looks like this, 2, and then inside parentheses, 2 plus 3. So it's different than these guys here because it was 1 plus the parenthesis part, or 1 times the parenthesis part. Now it's just 2 times the parenthesis part. It's similar to this, we just don't write the X in between there. But what this means is I'm going to multiply the 2 by the first number and the 2 in front by the second number. So this is what? 2 times 2. And then I have a plus sign here. And now I'll multiply it again. 2 times 3. So we get what? 2 times 2 is 4. 2 times 3 is 6. So this is equal to 10. The other way we could have done this is what? Our PEMDAS that you guys have learned, 2 plus 3 is 5. 2 times 5 is 10. So we get the same answer whether we use the distributive property or we use the PEMDAS. So that brings me to the last part of this video, PEMDAS. You guys have probably learned that forever. It was what? It was please excuse my dear Aunt Sally. Well, I have some sad news for you. All these years, they've been leaving a piece out. They didn't tell you that Aunt Sally has passed away. So it was what? please excuse my dear Aunt Sally. And these all stood for what? P, parentheses. The E was exponents. The M was multiplication. D, division. A, addition. And S, subtraction. But again, the problem with them trying to make you feel good and not tell you that unfortunately she passed away is what? You just always did it in this order. If there's multiplication, okay, I got to do the multiplication first. If there's division, then I do division. But the problem is, as I said, she passed away, so let's say now it's our late relative. So you need to relearn this as, please excuse my dear late relative Aunt Sally. And why is it important that she passed away? Well, because L stands for left and R stands for right. And this is so critical to our order of operations. We must do multiplication and division left to right. And let me give you an example. And you guys have probably seen this on social media. About every 6 months, one of these will make the rounds, and everybody gets into big arguments, and everyone loses friends over it because they're saying, no, this is the answer, and they say, no, this is the answer. Well, now you can chime in with the real answer. And let's say we have the following. 6 times 4 divided by 8 times 3. So the old way, when Aunt Sally was still alive and kicking, we had what? Oh, do multiplication first. 6 times 4, 24. Do multiplication first. 8 times 3 is 24. 24 divided by 24 is 1. If you answer that on the midterm or the exam 1, or the praxis, say my answer is 1, wrong. It's not correct. And again, half of social media is going to say the answer is 1 and they're adamant about it. They're wrong. Because we have to go left to right. So when we do that, move left to right, we have multiplication. 6 times 4 is 24, divided by 8 times 3. Still going left to right. 24 divided by 8 is 3. 3 times 3 is 9. Your answer for that problem, your answer for social media, you can make yourself look like you know what you're doing and are a math genius. The answer should be 9. So that's it. That's the end of video 1. You guys, I will let you know what homework you need to do for that. You can do that homework prior to class. If you are watching this on YouTube for practice review, that should give you a good base as far as the numbers, the number systems, what are integers, what's the number line, absolute value, PEMDAS. So come on back for video 2 and we'll learn a little bit more.